Hi, this is Tom. Welcome to my channel. So this is part 2 of a video dealing with a math theorem. So you can watch this video if you're not interested in math. This is for those that are interested in web development. So part 1 is math video that talks about the math theorem that's being proved here. And then this video is about how the web app was built that does the proof. So I'm just going to show this very quickly what it looks like. I'm not going to go into the math at all. But the first part is just showing the kind of intuitive idea of the proof. And then here it goes into the actual elements of the proof. And describes what's happening. And then here at the end you have a formal proof, such as you might see in a math textbook. Okay, so now let's take a look at how this was built. So I built this using Gemini, and I used the canvas to take a look at it here. All right, so here is the web app that was built, and I had a prompt that I used, which I will see if I I should be able to figure out a way to share the prompt that I used. And just look in the description of the video if you want to find it, and it'll tell you how to find the prompt. Okay, so the way that this was built was I started off in the session and I just told it like what I wanted to do. And this is a typical way, like I didn't know exactly where I was going, but I started here with another theorem. And at first, I was using AI within the canvas part of it. And so just to explain a little bit of where I was coming from on this was I had the idea of trying to enhance the UI experience with when you're looking at a chat. So what's happened throughout time is that you have sort of an oscillating effect with the PC that we have now, where it becomes like either dumb or smart. So at the beginning, you had a dumb terminal that did time slicing with the big brain computer. And then when PCs came about, then the PCs became powerful enough to where they could share in the workload. And so you had client-server technology developed, where the PC would show like Windows widgets. You could have drop downs, click on different buttons, do different things, and show the data in a really nice, pretty way. And the data itself would be housed on a server. And this was called client server, or two-tier technology, because there was two parts to it. And then when the internet came, then the PC became dumb again, and everything that happened of importance was done on servers. And all the PC was doing was just showing HTML. And then as time went on, there were ways figured out to leverage the power of the PC. And so you had things like Flash technology, and JavaScript was enhanced to where it could do a lot of things in the browser itself. And then the next phase of dumbness came with AI, to where in a chat session, you're not using the PC for anything. You're just sending text to the LLM on a server, and it returns you text. And so what's happening now is there's a lot of interest in using the client to do more things, and it's just this pendulum keeps going back and forth. And what I was wanting to work on here was a way of enhancing the UI experience. And so I built this for my own use to study math theorems. And so this is just using Canvas. So you click on the canvas, and I'm asking it to build a web app for a given theorem. So after I did that a couple of times, so it had a context, I got to this point here, and I asked it to create a prompt for itself. And this is a really powerful way of using AI, and this is a very common workflow that I use all the time. And that is, I start off a session, I'm not sure exactly what I want to do, but after a certain point, I get to something that I like, and then I want to capture it. And then a good way of doing that is to ask it to write a prompt for itself that does the things that you've been doing. So that's what I did here. It says, please write yourself a prompt that works like this. You'll ask me for a math theorem. You'll see how many tabs are needed. So this particular proof had 3 parts to it. So I asked it for 3 tabs. So that's what's happening here. It says you'll see how many tabs are needed, and then you'll write code similar to the one that you just did. So the code that wrote this, that it looks like this. And that will work with the theorem that I'm interested in. And then, it wrote out the prompt. It said, here's the prompt that you want. And so then I saved it in a Google Doc. And that's this prompt here. And this is the one that I'll share with you all. And I'll write a URL in the description of the video, so you can grab this prompt and just give it to. I've only tried it. I haven't tried it with Claude, but I'm like virtually certain Claude would do a good job with it. I tried it with ChatGPT and was disappointed with it. It had trouble managing it, but with Gemini it works perfectly. So Gemini just does it like first time, looks good, works. And I suspect Claude would be the same way. Okay, so I think, let me just think a moment. I think that's everything that I needed to share. I think so. So I will include in the video 2 links. So one link will be for the web app itself. So that will be this link. So you can look at the web app. Oh, I'm going to do this really simply here. I'm just going to have one link. All you have to do, if you want to get just do it this way. You don't need the prompt to build it. All you need to do is just do a right mouse click and then do view page source and just grab the code and just give it to Gemini or whichever AI you're using, and just say that you want to have it build web apps where they look like this, where it asks you for a math theorem that you're interested in, and it will create a web app that looks like this. That's going to work fine for any of, for Grok, ChatGPT, Gemini, or Claude. I mentioned that there were some difficulties with ChatGPT. The difficulties were looking at it in the canvas. If you ask it to build a web app, giving it this code as a pattern, it's not going to have any problem with that. You'll be able to deploy it or look at it in your own browser. You just save it as an HTML file, double click it, won't have any problem. Okay. Well, I hope you found that interesting and helpful, and until next time, thank you for watching.